So we were looking at concepts of basic object-oriented programming in C#. And as we have discussed, there are three concepts, right? Encapsulation, which basically means creating a class, okay? And not only we put the related data and the related functions inside the class, okay? Pretend these are the variables or the data, the boxes are the functions or the methods, right? We also wanted to follow good object-oriented programming principles. In good object-oriented programming, so in good OOP, we keep data hidden. And how do we indicate the data is hidden inside the box? Through what type of keyword? Private keyword, right? So the data is always marked private. So for this to be useful to the programmer, the methods over here are public. So the functions are also called methods, right? Okay, so that's the encapsulation mechanism, meaning take related data, related methods, put them in some kind of a class. We may give it some name, for example, class student as an example, right? Okay. So we created the student class last time. And for example, we put, rather than 2 fields, we put 5 fields over here. And we added, for example, one method called compute break last time, if you remember, right? Okay, so when we are creating a large application, we don't just create one class, we create many classes. Okay, so this is where the inheritance comes into play. So inheritance, basically when many classes are created. Okay, often they have common things in between them. So that's the basic idea in inheritance, okay? Rather than copying and pasting those common things, we take those out and create what is called the base class, right? So for example, let's pretend we are creating a university application. Okay, in a university, let's pretend we will have, let's pretend we have 5,000 undergraduate students. And let's say we have 2,000 graduate students. Okay, and let's pretend we have 100 PhD students. Okay, and let's pretend we have 500 part-time students. So, as we discussed, anytime you have to create an application, the first question that comes to, where a lot of people get stuck is, where do I start? Okay? So the starting point is always to identify the entities that exist in our real life. Okay? So that exist in real life. Okay. For example, in this case, in a university, these are the objects or entities, or however you want to think of it. These are the real things that ultimately we need to store data for, right? So we'll start out by creating a class for an undergraduate student, class for a grad student, class for a PhD student, class for a part-time student. As we are writing the code for these, we'll recognize, hey, we are repeating things, okay? So this is where the inheritance comes into play. We'll take out the common things and move them to a base class. This way, the total amount of code that we have to write will be less, okay? So see, the goal of inheritance is, very simply to write less code, okay? Because they've done studies, if you create a large application, Okay, if you have, let's say you wrote 100,000 lines of code in creating an application, right? Somebody creates the same application in 20,000 lines of code, okay? Which one is easier to maintain? Of course, the less lines of code, it's easier to see, easier to change, easier to modify. So that's why whenever we do programming, our goal is to write as less code as possible, right? And that's why, you know, even in the programming languages, okay, somebody might say, oh, you know, why you have to write it in C#? Why don't you write it in some language, X, for example, right? Okay, sure, anything you can do over here, you can do it in another language, for example, Java, C++, and so on. But ultimately, what if it takes you shorter time over here? What if the total amount of code is less over here? See, that's what will dictate, for example, if one language is better than the other, right? Okay, so even in C#, for example, if you, remember I said when it was introduced in 2000, the version of the language was 1.0, then 2004, 2.0, and so on. 2015, the version of the language, I forgot it's 5.0 or 6.0, one of the two, right? So the same code, if you write it now, you'll be surprised if you wrote it back over here. It's like 10 times shorter, okay? So anyway, we'll come to that part as we go along. But fundamentally speaking, why do we do inheritance? So that we write less code. Okay, so the question is, what is the key idea in inheritance? So last time we did a small example. Okay, we created a class called student, for example. Okay, and in this student class we had 5 fields, if you remember. First name, last name, ID, test 1, and test 2, right? And we also wrote one function over here, compute grade. Okay, and let's pretend this compute grade first computes a weighted average where 40% of the weight is given to test 1, 60% of the weight is given to test 2, let's pretend. And then based on that, if it is greater than 90, the grade will be A, and so on. Okay? So we wrote this class, right? So because we are creating a university application, after creating a student class, or let's call it undergraduate student rather than just a student. Okay, so let me change the name to undergraduate student, right? So now you start to create a grad student, okay? So let's start writing the code for grad student. So as we discussed last time, will a grad student have first name?
Yeah.
Yes.
Last name, ID, test 1, right? So the first 5 fields will be the same. So one option is we just copy it over here. Okay. Now in inheritance, the rule is, okay, you inherit everything from the base class or the parent class. Okay. Okay, so to clarify this, let's say you created some class called X and you put 3 fields and 2 methods over here, right? Then you created a class called Y. Okay, and in C#, remember we use the colon syntax to indicate we are inheriting from X. Okay. So if we just write this and we don't type anything, any code in it, just the begin curly, end curly. Okay, as far as class Y is concerned, will it have these 3 fields? Yes. Will it have these 2 methods? And that's what I meant. You inherit everything. So if you have X number of fields, you will inherit those. You have Y number of methods, you will inherit those, right? So you inherit, in this example, the 3 fields, 2 methods will all be available over here. Okay, now the other rule in inheritance is, okay, you can add more fields or methods, your choice. So as you inherit, so in class Y, you can add more things if you feel like it, okay? So for example, if I tried, if I put 2 more things over here, 1 more method over here, so how many total fields and methods do I have in class Y as of now? So 5 fields and 3 methods. 2 are being inherited, 1 we added extra. Okay, so that's perfectly okay. Not just C# and Java and C++, all languages that follow the object-oriented programming, these rules are universal. Okay. Now the next rule you need to remember is, again related to inheritance, is okay, so one more rule, okay, you cannot delete an inherited field or method. Okay, so for example, okay, let's say you don't want the top field over here for whatever reason, okay? If you inherit it from here, you will always get this. There's no way you can remove it, okay? So because of these 3 rules of inheritance, you inherit everything, you can add more things, you cannot delete anything that you are inheriting from, okay? When we use inheritance, okay, we try to, okay, so let's say you created some class X, it has a few fields, a few methods, you created a class Y, let's pretend, it has a few fields, few methods, you created a class called Z. Okay, let's pretend it also has few fields and few methods, right? Now let's pretend that after you created the 3 classes, so far there's no inheritance between them. Okay, it turns out this is same as this one, also same as this one, okay? And let's pretend this blue method is same as this blue method over here, and also same as this blue method. So 100% same code, same signature, okay? And let's pick one more